All right, ladies and gentlemen, these are the notes I'd like you to understand and know about dilations. Page 2 in your packet. Remember, these are dilations about the origin. We are going to be dilating around different points later, but for right now, our starting point is 0, 0, and everything is dilating out from there. All right, this first triangle that we have here is very simply ABC, and we're going to start by writing down its coordinates. And when I scale factor this by a factor of 2, what I'm saying is multiply everything about the triangle by a factor of 2. So each coordinate is going to double. So it'll become 1, 3 becomes 2, 6, 1, negative 2 becomes 2, negative 4, 5, negative 2 becomes 10, negative 4. And I can connect the dots and make my new triangle, my new image. Remember, what we talked about in class is that the image of A will become A prime. The image of B I can label B prime. C I can label C prime. Okay? Dilations do preserve the angle measurements. So angle A is still congruent to angle A, but the sides all become proportionally larger. So we have, in fact, a similar triangle. ABC will be similar to A prime, B prime, C prime. Okay, by a scale factor of 2. If we wanted to write the ratio of ABC to A prime, B prime, C prime, I could write it as a 1:2 ratio. And again, a scale factor of 2. I will leave the problem next to it, problem number 4, for you to do on your own because it's a very similar situation. Problem number 2 is slightly different. I have a scale factor of 1/2, so I'm going to be taking each coordinate, labeling it, and cutting each coordinate by 1/2. So negative 2, 6 becomes negative 1, 3. 2, 6 becomes 1, 3, and 2, 0 becomes 1, 0. Again, I can connect the dots and label them A prime, B prime, C prime. I can see that my angles are again preserved. My side lengths have been scaled back by 1/2, and similarity is preserved. ABC is similar to A prime, B prime, C prime. My ratio in this case, ABC, is twice A prime, B prime, C prime. So I have a scale factor of 1/2. Okay, the next one I wanted to do, number 3 is a lot like number 2. I'll let you guys do that one on your own. The next one I wanted to do with you is number 5, because we have a fraction that is going to actually enlarge the triangle or the square here because it is a number greater than 1. Label your coordinates. And what you're going to do is multiply each coordinate by the 3/2. So 2 times 3/2 is 3. 3, 3. 4 times 3/2 is 6. The 2 times 3/2 is 3, and so forth. And you'll get your new square. We know all squares are similar. Let's say all I gave you was the 2 figures A prime, B prime, C prime, D prime, and ABC. If I wanted you to back up and figure out the scale factor, the easiest way to do it is to compare your new information to your old information. So let's just look at, for instance, the x-coordinate. I have 4 for my new I have 3 for my new A prime's x value and 2 for A's x value. I can compare those to see what my ratio is, and actually I don't even have to reduce it. 3/2 is my scale factor. Okay. If I was going to write this, I could say ABCD is similar to ABCD, all of them prime, And if I wanted to write it as a ratio, I could say it is a 1 to 3 halves ratio. People don't usually write that. They usually write it this way, a 2 to 3 ratio, multiplying through by 2. Okay. I will leave questions 4, 3, and 6 for you to do for homework. Thank you very much.